Welcome to calculus. Now, calculus is preceded by pre-calculus, which you studied last semester. So, we'll make use of what we looked at in pre-calculus. So, please, if you've thrown away the notes and you've forgotten about pre-calculus, please make sure you retrieve those notes because we'll need them, time and again in our discussion. We begin our discussion of calculus by looking at limits. What do we mean by a limit? To motivate our discussion on what is a limit, let's consider the following question. So consider the function f of x, which is equal to x squared minus 1 over x minus 1. Our interest is to find the number that the values of f of x approach as we take values of x closer and closer and closer to 1 without actually letting x to be equal to 1. Because if we let x to be equal to 1, then the denominator x minus 1 becomes 0, and we know very well that we don't divide by 0. So we're considering values closer and closer and closer and closer to 1. So for each of those values closer and closer and closer to 1, we'll be observing what is the value of our f of x. So for those values of f of x that we obtain, our interest is to see what are these values approaching? What number are these values approaching? Now, immediately, that should give you a sense of what is happening here. So ideally, we're picturing this one on the number line. We know that if you picture this one on the number line, you have numbers to the left of 1 and also numbers to the right of 1. So we'll be considering numbers to the left of 1 which are closer and closer and closer to 1. So basically numbers less than 1 but closer to 1. And also numbers to the right of 1. So basically numbers which are greater than 1 but closer to 1. So for each values of x, for each of these values of x, we evaluate what is our f of x and then look at what number are these values of f of x approaching. So we can start with values to the right of 1, values greater than 1 but closer and closer to 1. So we can start, for instance, with x equal to 1.5. If we take this x to be equal to 1.5, we evaluate what is a f of 1.5. So we replace x with 1.5. What's f of 1.5? Well, plug and play. We get f of 1.5 is equal to 1.5 squared minus 1 over 1.5 minus 1, which is what we have here. Now, 1.5 squared gives 2.25. By the way, you're allowed to use a calculator. So we get 2.25 minus 1 over 1.5 minus 1, and that reduces to 2.5. Now, that's the value of f of x when we take x to be equal to 1.5. But remember, what we're doing is we're considering values closer and closer and closer to 1. So let's consider a value of x much closer to 1 and see what would be our f of x. Well, we had x equal to 1.5 here. We're getting f of 1.5 is 2.5. So f of x, that's f over 1.5 gives 2.5. Well, we can as well start with x equal to 2, in which case we're going to get f over 2 is 2. So we consider a value of x much closer to 1, but to the right of 1. So we can consider, say, 1.1. It's actually much closer than 1.5. Well, our f of x is going to be f of 1.1. Well, f of 1.1, which will give us 1.1 squared minus 1 over 1.1 minus 1. Well, using a calculator or other means, we get f of 1.1 gives us 2.1. Now remember, we're considering values closer and closer and closer to 1. Well, let's get a value much closer to 1, closer than 1.1. Well, we can pick 1.01. So our f of x is going to give us a f of 1.01, which gives us a 2.01. Well, we can try another value much closer to 1, say 1.001. Well, at least it's much closer than the other values here considered. So our value of f of x is going to give us a f over 1.001, which gives a 2.001. Well, you can try a value much closer, say 1.00001, and see what you get. For me, well, I guess I'll just stop there. But for you, you can keep going. Well, remember we said we'll consider values on the right of 1, that is values greater than 1, but also values on the left of 1, that is values less than 1. So let's try now values less than 1 but closer to 1. So we can start with x equal to 0 and see what is our f of 0. Well, f of 0 is going to give us 0 squared minus 1 over 0 minus 1, which gives minus 1 over minus 1, which gives a 1. So we get that when we let x to be 0, f of x gives us 1. Remember, we consider values closer and closer to 1. So let's try to get closer to 1. We can be satisfied with just f of 0. Let's consider something closer to 1. Let's take 0.5. At least it's closer to 1. Well, f of 0.5 is going to give us 0.5 squared minus 1 over 0.5 minus 1. By the way, take this as a lecture. So make sure you have a pen or a pencil and a paper, and make sure you write down whatever we're discussing here and make sense of it. You are at liberty to pause the video, write down, make sense of it, and get back to it. So take x equal to 0.5. Can you please evaluate f of 0.5, which is going to give us 0.5 squared minus 1 over 0.5 minus 1. Evaluate that. Don't just watch, try to evaluate it and see that you get f of 0.5 is 1.5. Well, we can consider a value much closer to 1, say 0.9, and evaluate what is f of x, which is f of 0.9. Try to do that and verify that the value that we obtain is 1.9. Well, we can consider a value much closer to 1, say 0.99. Evaluate what's f over 0.99. I'm sure you will get 0.99. How about we get much closer to 1, say 0.999. Well, the value of f of x is going to give us our f over 0.999, which, please try it, you should get 1.999. You can go on and on, say consider 0.9999 or 0.99999 or 0.9999999. Get closer and closer to 1. Now, from the data obtained here, we see that as we're approaching x equal to 1 from the right, the values seem to appear to be approaching 2. Similarly, as we take values of x closer and closer to 1, but on the left, approaching 1 from the left, it appears again that our values seem to be approaching some number. Well, looking at the data here and the data here, it appears that our values of f of x approach 2 as x approach 1. So we see that the closer we get to 1, values of f of x get closer to 2. So this seems to suggest that, values of f of x approach 2 as we take x closer and closer and closer to 1. Now, there's a terminology for this. We say that this value, that values of f of x are approaching, which in this case is 2, as we take x closer and closer to 1, this value here, we call it the limit of the function f of x as x approach 1. So we say 2 is the limit of the function f of x as x approaches 1. And we write this as such. So this is pronounced the limit of f of x as x approaches 1 is 2. Meaning to say that as we take values of x closer and closer and closer to 1, values of f of x get closer and closer and closer to 2. Now remember, for the limit here, we are considering values closer and closer and closer to 1. Not necessarily x equal to 1. We're not necessarily letting x equal to 1. We are considering values closer to 1. That's the reasoning behind the limit. That for the limit, we are considering values of x closer and closer and closer to the given point, not necessarily taking x equal to that. So our interest is what is the value that f of x approach as we let values of x get closer and closer and closer to 1, but not letting it to be equal to 1. Now remember, our f of x is x squared minus 1 over x minus 1. So we can write this equivalently as the limit as x approaches 1 over x squared minus 1 over x minus 1 is equal to 2. Remember, this is our f of x. So we have that as we let x get closer and closer and closer to 1, values of f of x here approaches 2. So we write that as the limit as x approaches 1 of our function is equal to 2. So the formal definition is that, we write the limit of f of x as x approaches a is equal to L. Pronounce the limit of f of x as x approaches a equals L if we can make values of f of x as close to L as we like by taking values of x as close to a but not equal to a. So in our discussion, the preceding discussion, if we let f of x to be x squared minus 1 over x minus 1, then our limit, the limit of f of x as x approaches 1 is 2. So that means that, values of f of x get close to 2 as we let values of x get close to 1. Now remember, what we did here was to consider values to the right of 1, so approaching 1 from the right, and here we approached 1 from the left. Now, by the limit, we mean, the limit as x approaches 1, we mean approaching 1 from either side, from both the left as well as the right. But we can also confine ourselves to just one side. So we may be interested in, say, finding what is the value that f of x approach as we approach a from the left. If we confine ourselves, just approaching a from the left, what we get is referred to as the left-hand limit over f of x. So the left-hand limit of f of x as x approaches a equals L. What that means is that, as we are approaching a from the left, that is, as we consider values of x less than a but closer to a. Remember, those that are less than a are to the left of a. So, as we approach a from the left, the values of f approach L. That is a left-hand limit over f of x as x approaches a. And that is denoted as such, so that power, which is a negative, notice that it's not negative 1, it's just a minus. So this means that we are approaching a from the left, and as we're approaching a from the left, values of f are approaching L. That gives the left-hand limit. So the left-hand limit of f of x as x approaches a equals L. If we can make values of f of x close to a as we like by taking values of x close to a but less than a, that is but to the left of a. So that is the left hand limit. And remember, by the left hand limit we mean we are considering values of x closer to a but to the left of a, but less than a. And as we do that, values of f of x are approaching L. So that means the left-hand limit as x approaches a of f is L. Similarly, if we confine ourselves to the right, approaching a from the right, we get a right-hand limit denoted as such. So the limit, the right-hand limit of f of x as x approaches a equal to L. This means that, well, we are considering values of x closer and closer and closer to a, but to the right over a, so greater than a. And as we do that, values of f of x are approaching L. Now, so from our table here on this side of the table, we are approaching 1 from the right. So we're considering the right-hand limit as x approaches 1 of f of x. We seem to see that our values of f of x approach 2. And here we have the left-hand limit. We are approaching 1 from the left. We also see that the values approach 2. So that's why we had to conclude that, well, approaching from either side we get 2, because we see that we're approaching it from the right. That's the right-hand limit gives us 2. The left-hand limit gives us 2. So what that means that, well, the limit exists if both the left-hand limit and right-hand limit are equal. So if we have that, well, the left-hand limit is L and the right-hand limit is also L, then that means that the limit as x approaches a exists. That is, if we approach a from either side, we get L. So the limit exists. But if they are different, if the left-hand limit is different from the right-hand limit, well, that means that, well, the limit does not exist. Let's consider this example. So here is a graph of some function, say g of x. We want to evaluate the limit, the left-hand limit of g as x approaches 2. As we take values of x closer and closer and closer to 2, but on the left of 2, what are the values of g approaching? Well, remember that the values of g are read off the graph. So if we consider, say, a value somewhere on there, 1.5, the value of g will be read off the graph. There will be the y coordinate of the point where the x coordinate is 1.5. So if we do that, we get that, well, the value is somewhere on there. But remember, by the limit, we are approaching the point. So we're approaching 2 from the left. Well, let's get a value much closer to 2. Well, we see that the value seems to be approaching a value. Get closer and closer and closer to 2. It seems that the values of g approach 3. So we can conclude, therefore, that the left-hand limit of g as x approaches 2 is 3, implying that as we take values of x closer and closer and closer to 2 from the left of 2, values of g approach 3. How about the right-hand limit of g as x approaches 2? That is approaching 2 from the right. If we approach 2 from the right, well, this is the graph. We see that, for instance, if we take a value at that point, well, the value of g is somewhere there. Let's try to get closer to 2. We see that the value of g is somewhere there. Get much closer to 2, it seems that the values are approaching 1. So we can conclude, therefore, that the limit, the right-hand limit of g as x approaches 2 is 1. So we see that, well, the left-hand limit and the right-hand limit are not equal. Does the limit as x approaches 2 of g exist? Well, the limit as x approaches 2 of g. Remember, if we're trying to find the limit as x approaches 2, we consider either side of 2. So approaching it from the left, we get 3. Approaching it from the right, we get 1. Are we approaching some particular value as we approach it from either side, from both sides? Well, we'll see that, well, we're not approaching a particular value, because approaching from the left, we get a 3. Approaching from the right, we get something totally different. The two are not equal. Approaching from either side, we're not approaching the same value. So that means that the limit of g as x approaches 2 does not exist. How about the left-hand limit of g as x approaches 5? So the values of x are on the x-axis. Our 5 is there. We are taking values of x from the left over g. What are the values of g approaching? Well, in other words, we're looking for the y coordinates as we take the x coordinates closer and closer and closer to 5. If we do that from the graph, it appears that, well, the values approach 2. So we get that the left-hand limit of g as x approaches 5 is 2. So approaching 5 from the left, the value of g approach 2. How about the right-hand limit of g as x approaches 5? We're approaching 5 from the right. From the graph here, it appears we're also approaching 2. So we have that the right-hand limit of g as x approaches 5 is 2. Well, the two are the same, so it follows that the limit of g as x approaches 5 is 2. Well, that's a graphical illustration. For now, if you're not given the graph, well, we may try using the table as we did in this illustration, just for now. But we'll explore other means later on. So for now, here's your turn. Would you please find the limit, if it exists, the limit as x approaches 1 over this function here, and the limit as x approaches minus 1 of this limit, and so on and so forth. So try to come up with a table. Consider values of x closer to 1 from the left and values of x closer to 1 from the right, and see what value the function approaches, and similarly for the rest. Before the next video, please make sure that you've done this and made sense of them. Have fun. God bless.